Okay, today we are looking at the second half of 3.3. So we've got 3.3 day 2, still dealing with these imaginary numbers. Today I'm thinking is going to be a little bit more straightforward than yesterday. The factoring and the simplifying can be a little bit tricky even without the standard form, or excuse me, even without the imaginary numbers. Whenever we're simplifying square roots, imperfect squares, that can be a little tricky. So today, a little more straightforward. It's kind of like basically just combining like terms type of situation and simplifying through multiplication and addition and subtraction. So one thing I do want to show you guys here, this is considered your standard form for imaginary numbers. Okay, so what's considered your standard form is when we've got that real number first and followed by the imaginary number. Okay, so you're always going to have that real number first and then adding or subtracting that imaginary number off the back. So one thing I want to show you is like the case here where we've got something like 4 plus 3i. So this would be like an example of a final answer today. Okay, this is an example of a final answer today. And then you guys aren't going to have to do this part, but I just wanted to show you this is what we're talking about with these imaginary solutions. We're used to having solutions right on our x-axis, right? Something like -4 and 1. But here in this case, where imaginary numbers helps, is this is how you graph and evaluate that imaginary solution. Okay, it would be up here. We can see that that's not a traditional solution on the x-axis like we're used to seeing, but this is where these things come in handy. Those imaginary solutions that are off just floating in wherever on the coordinate plane. And that's where this helps us out and where this is useful in evaluating those graphs. So with the actual problems that we're dealing with today, we're just combining these. So you're going to have to either add or subtract. So we're going to see one example of each of those here. First of all, when you're adding two binomials or two grouped expressions, when you're adding them, those parentheses really don't mean anything because you're not distributing anything. There's not something to multiply through. Okay, so when you're adding grouped expressions, it's really just everything being thrown into one big addition. So when we're going to combine our real numbers with our imaginary numbers, excuse me, your real numbers, you're just combining these like we're used to combining like terms. We have a -5 and a -6. So I'm going to combine those, -5 plus a -6, or it's the same as just -5 minus 6 more. Either way, that's going to end up equaling -11. So you're just combining those two real terms, and then we're going to go ahead and combine the two imaginary terms. So your imaginary terms here are the 6i, a positive 6i, and a positive 8i. So imaginary is going to be 6i plus 2i, and it's just like combining x terms or y terms. We have a positive 8i for our imaginary number, and then like we talked about in that standard form, okay, we talked about this standard form on the last slide right here. That's just how you want to make sure you're presenting your answer. Okay, so you've got -11 plus 8i. And that is your final answer for today's stuff. That's all you're doing. You're combining those reals and the imaginaries with each other. Okay, so the next example, one little difference here is that we've got that subtraction happening. So I'm subtracting this entire back binomial. So I'm subtracting -2, which is really adding 2, right? And I'm subtracting a positive 4i, which is -4i. So really what's happening is like I'm distributing this negative. It's like I'm multiplying everything by -1 before I can actually combine. Okay? So that make sure you're subtracting a -2, which is adding 2, and then subtracting a positive 4i, which is -4i. So then that -4 plus 2i out front stays the same because there's nothing in front of there, okay? and now you're able to combine everything with those parentheses gone. So the only difference when subtracting is you have to subtract each of those terms like you're distributing a negative. So now it's the same thing, okay? So now I've got my real numbers, which is going to be -4 and 2. So I've got -4 plus 2 is going to equal -2. And my imaginaries, which is going to be 2i minus 4i. And that's going to equal -2i. So your final answer here is just -2 minus 2i. And that's the first 4 problems on your homework on Alex, is just combining by either adding or subtracting those binomials. Now, when we get into multiplying, the second group of 4, so there's 8 problems on your homework, the first 4 are either adding or subtracting the groupings. The next 4 are multiplying, okay? So this is when you've got one of 2 options. Personally, I like to just distribute everything, okay? Which is like foiling. That first outside, inside lasts, okay? So we've got -6 plus 4i times -3 plus 6i, okay? And we're just going through this in that FOIL order. We're distributing each term from the front with each term from the back. So first is going to be that -6 times -3, which is going to be a positive 18. That O is outsides, so -6 times a 6i. So that's just -6 times positive 6 is -36, and there's just an I attached there. It's -36i. The I in FOIL is for inside, so now you're distributing the second term with both of the terms in the back. So 4i, 4i times -3. 4 times -3 is -12, and there's an I involved, so it's -12i. And then that last is going to be 4i times 6i. Now here's where something that has to do with our imaginary rules comes into play. So 4 times 6 is going to be positive 24, and it's an I times an I, so it's I squared, okay? Just like if I had 2x times 3x, I would have 6x squared, right? So I get that I squared term. Now here's where that's going to come in handy. So first of all, we have to combine all the like terms. Well, whenever you FOIL, that outside and the inside product are going to be like terms. So if I have matching I values, just like when we combined the problems, the first 2 examples, we combine our I terms with each other, right? So if I have more than one I term here, I have to combine them. So right now, I've got that 18 that's staying put, -36i and -12i combined to -48i. And then here's what's happening with this I squared. If you guys remember from our rules, remember that the square root of -1 equals I, and I squared equals -1. So we have a way of turning that into a value. So 24 times I squared is actually 24 times -1, because I squared is equal to -1. That's all that happens. So then I have 18 minus 48i minus 24, because 24 times -1 is -24. Then one extra thing that you need to be careful with, if you were to type this into Alex, it would say you need to further simplify your answer. Well, that's because when this turns into -24, I now end up with 2 more like terms with these real numbers. 18 minus 24 is -6. So my final answer is actually -6 minus 48i. Okay? And then just so you guys can see this in another way, if you don't want to do the distributive form here, you can do the box method. So you're going to have a box. Some of you may learn how to multiply binomials this way. So you're going to put one of those binomials along the top and another one along the bottom. So I'll put -6 and 4i, so -6, 4i, and another one along the left-hand side, -3 and 6i. And it's kind of like you're just finding the area of each of these boxes, because when we're foiling, we're just making sure that everything from the front is being distributed to everything from the back. And this box method does the same. Okay, see how I end up with 4 pieces here? I'm going to end up with 4 pieces in this box. So -3 times -6 is going to be a +18. -3 times 4i is going to end up with -12i. -6i times, excuse me, that's a +6i, that's my fault. Get that out of there. So it's actually 6i times -6, that's going to be -36i. And then 6i times 4i will be 24i squared. Okay? And then you just need to make sure that these 4 terms, notice how whether you're doing the FOIL method or the box method, you end up with those same 4 terms that we did over here when we FOILed. Now we just need to do the same thing where we combine the like terms. Okay? So -36i and -12i are going to combine to be -48i. And then you make sure that this I squared, remember I squared always equals -1. So 24 times -1 is going to equal -24. So then you also have to make sure that that 18 and that -24 get combined, because they're both real terms. They're both real numbers and constant terms. So we've got a 18 minus 24 is going to give me -6. And then that -48i came out of combining the 2 I terms. Okay? And then you notice that we get the same answer. So those are probably the 2 easiest ways to make sure that you are fully distributing. So let's look at one more example here. We're going to end up with multiplying these 2 pieces. I like the FOIL method. If you want to do the box method, that's fine. But just to keep this kind of quick for you guys, we'll just go through FOIL here. So my first multiplication is 4 times -5. That's going to give me -20. My second multiplication is the outside. So it's going to be 4 times 2i. That's going to be a +8i. My third multiplication is now on the second term in the front grouping. So I have -3i times -5. That will be a +15i, because a negative times a negative is a positive. And then that last, the L in FOIL, -3i times 2i. So -3 times +2 is -6. And then since there's an I times an I, it's I squared. Okay? Again, let's make sure that this guy gets turned into a -1. So we really have -6 times -1, which is equal to 6, a +6. And now we're just combining our like terms. So I end up with -20 and a +6, okay? So that's going to end up being -14. -20 plus 6 will be -14. And then my +8i and my +15i, 8 plus 15 is going to be 23i, and that's my final answer. So make sure that we are seeing this I squared piece. That's the one part of this that involves the rule. Other than that, all of your examples or all of your homework are going to look like these 4 examples. Use this video to help you out if you have questions. And then that is going to be the end of our 2-day 3.3 section.